In these problems, we're being asked to find the exact values of some trig functions, and you've probably done this before. You've probably been asked what's the cosine of pi over 4, and you've gone straight to a unit circle, and you've reminded yourself that the cosine is the x value, and you've looked at pi over 4 and seen, oh yeah, it's the square root of 2 over 2. I think they put this topic in here because they wanted you to do this without a unit circle so that you could learn where the unit circle came from, why it looks the way it looks. Why do we have pi over 4, pi over 6, pi over 3, and not some other fractions of pi? Well, the reason is because of special triangles. There are some triangles that we know the ratios to. For example, the 45-45-90 triangle, you might remember, has two sides that are the same, and a 45-degree angle here and a 45-degree angle here, and the ratio of the sides is 1 to 1 to the square root of 2. The other special triangle you might be familiar with is a 30-60-90. And in this one, so 30-degree up there, we would have sides in the ratio of 1, a hypotenuse of 2, and this side is square root of 3. Now these numbers should already be ringing some bells. Look at the fractions we have around the unit circle. We've got a bunch of square roots of 2's, square roots of 3's, and 1's and 2's. This is where those numbers are coming from. So I want to show you how that's the case as we do these problems. So if I were to put that unit circle aside and just draw my own circle to try to find the cosine of pi over 4, I might start like this. And what I've done is tried to draw in a line at the fourths of pi. So here's 0, here's pi over 2, and right in the middle, cut this in half, is pi over 4. And the other fourths of pi are around the circle. Now, we want to find the cosine of this angle. To do that, we're going to drop a perpendicular down to the x-axis. And then we're just going to use our trig. We know that the cosine is the adjacent side over the hypotenuse. This triangle that I've just made is a 45-45-90 triangle. How do I know that? Well, this is 90 degrees, and I cut that in half to get pi over 4. Pi over 4 is half of pi over 2. So this is 45, this is 90, so this must also be 45. Therefore, the ratio of the sides, 1 to 1 to the square root of 2. And now the cosine is the adjacent side, that would be this side, over the hypotenuse, so that would be 1 over the square root of 2. And that's doesn't look like exactly what we got, but we still have to rationalize the denominator here. And when you multiply it by the square root of 2 over the square root of 2, you're going to get the square root of 2 over 2. And that's exactly what we have here for the cosine of pi over 4. Now, something similar is going on for thirds and sixths of pi, and I want to show you that too. So we're going to find the cosine of 4 pi over 3 without referring to the already calculated out unit circle. So what I've tried to do here is just draw in lines at thirds of pi. So here's pi over 3. This would be 2 pi over 3. Here's pi, which is 3 pi over 3. And then this would be 4 pi over 3. And that's what we want to find out. So we're looking for this angle here. We're going to use the x-axis to make a reference angle. We'll drop the perpendicular. So there's our triangle. Now this is a 30-60-90 triangle. How do I know that? Well, from here to here is 1/6 of the circle, because I was dividing these at the third marks. So there's actually 6 of those as you go around the circle. They're all even. 360 divided by 6 is 60. So this angle is 60, and which means this angle's got to be 30 because this one up here is 90. Now our ratios for a 30-60-90 triangle, we have 1, a hypotenuse of 2, and square root of 3. If I'm trying to find the cosine of this angle, I want adjacent, which is 1. That's this line right up here, that side, and the hypotenuse, which is 2. And then I have to ask myself, what's the sign? In the first problem, I was in the quadrant 1, so I know everything's positive here. For the other quadrants, you have to remember, is x positive, or is x negative, or is y positive, or is y negative if you're finding the sign. In this case, we're down in the third quadrant, so everything's negative. So I know that the cosine of 4 pi over 3 is negative 1/2. So that's how to find some exact values of trig functions using your knowledge of special triangles.